You know that feeling when an app just works? It feels smooth, it doesn't crash, it does exactly what you expect? Well, that's not magic. It's smart testing. So today, let's pull back the curtain on one of the most powerful secrets in a software tester's playbook, boundary value analysis.
Okay, so picture this. You're the one testing a brand new app, and there's a simple field for age. The rules say it only accepts ages from 18 to 99. Now, how do you make sure it really works? Do you have to sit there and type in every single number? 18, 19, 20, all the way to 99? And what about the ones that shouldn't work, like 17 or 100 or even 0? That sounds exhausting, right?
And that's really the heart of the problem in software testing. You simply can't test every single possible thing. It would literally take forever, and you'd run out of money. But the good news is, you don't have to. There's a much smarter way to hunt down the problems that actually matter.
This leads us right to a fundamental challenge in making quality software. It's a problem so common that testers just call it the impossible testing problem. See, this idea of trying every single input, every age, every name, every click combination, has a name: exhaustive testing. And honestly, it's a trap. Because in the real world, it's pretty much always impossible. You'd never ship the products. So if we can't test everything, how do we get any confidence that the software is ready? Well, we need a strategy.
And that strategy all starts with breaking the problem down into smaller pieces. Instead of trying to boil the entire ocean of possibilities, we're going to create a few small, manageable ponds. We're going to partition it. The first big idea here is something called equivalence partitioning. Now, I know, it sounds super technical, right? But the concept is actually incredibly simple. You just divide all the possible inputs into groups, or partitions, where everything inside one group should be treated the exact same way by the software. So for our age example, you'd have 3 groups: one for ages that are too low, one for ages that are just right, and one for ages that are too high. Simple. And here's the magic. Instead of testing all 82 valid ages, you just pick one, maybe 40. The whole idea is that if the number 40 works, then 55's probably going to work too, and so is 73. By just testing one single representative from each group, you slash your workload, but you still cover the basic logic. But wait, we can get even smarter than this. Because as it turns out, not all values inside a group are created equal. The most interesting stuff, and let's be honest, the most dangerous stuff, happens right on the edge. And this, right here, is a golden rule of software testing, learned from decades of experience. Bugs love to hide at the boundaries. That one single point where the code has to make a decision: is this value in or is it out? That's precisely where off by one errors and other mistakes are most likely to happen. And this table just lays it out perfectly. Equivalence partitioning, or EP, picks a nice, safe value from the middle of the group. But boundary value analysis, BVA, is a precision strike. It goes right for the trouble spots: the values at the edge and the values immediately on either side of that edge. It's the difference between a random check and a targeted inspection. I think the best way to visualize this is the fence analogy. Imagine the boundary is a fence in a yard. BVA doesn't just check what's happening in the middle of the yard. No, it goes right up to the fence. It checks what happens when you're standing with one foot just inside the fence, what happens when you're standing right on the fence, and what happens when you step just outside the fence. Those 3 spots are where things are most likely to go wrong. Okay, that's enough theory. Let's make this real. How does this actually work? Well, let's use a delicious example. We're going to order some pizza. The process itself is really just a simple, systematic recipe. First, you figure out your valid ranges, like how many pizzas can you order. Then, you define what's valid and what's invalid. After that, you pinpoint the exact boundaries, those fence lines. And finally, you pick your test cases right on and around those boundaries. So let's apply that recipe. Let's say our app lets you order between 1 and 10 pizzas. Instead of testing some random number like 5, we use BVA. We go straight to the lower boundary. We'll test 0, which is just below the limit. We expect an error message. Then we test 1, right on the boundary. That should work. And we'll test 2, just inside. That should work too. Now let's jump to the upper boundary. We test 9, just below the max, which should be fine. We test 10, right on the upper limit, expecting success. And finally, we test 11, just one step over the line, which should give us an error. And boom, with just those 6 highly focused tests, we have incredible confidence that this feature is solid.
So what's the payoff for thinking this way? What do you get? Well, you get what we can call the smart tester's edge. BVA is a total game changer for a few really important reasons. It is incredibly effective because you're fishing exactly where the fish are. You're looking for bugs where they're most likely to be. It also drastically, and I mean drastically, reduces the number of tests you need to run, which saves a ton of time and money. And finally, it gives you a clear, systematic process that anyone on the team can understand and use. And if you want a visual, this says it all. Look at that difference. On the left, you have exhaustive testing, a skyscraper representing thousands, maybe even millions of tests for a complex system. And then, all the way on the right, that tiny little bar, that's BVA. That's the power of working smarter, not harder. Now, of course, BVA isn't a silver bullet. You gotta know where to use it. It works best on things you can count or put in order, numbers, dates, things like that. It's not designed to test complex business rules. That's why smart testers use it as one powerful tool in their toolbox, alongside other techniques to make sure everything is covered. So here's something to think about. The next time you use your favorite app and it just works, when you book that very last seat on a flight or order the maximum number of an item allowed and it goes through flawlessly, just take a second. Because now you're in on the secret. You know its perfection is probably thanks to a very smart tester who knew exactly which hidden edges to check.